In this video, I'm going to show you 4 different examples of solving systems of equations using a Casio FX9860G2. So when I turn my calculator on, I need to go to menu 5 for graph. If you look at the menu screen, you see the graph option is number 5. You could press the down arrow and execute, but I think it's faster just to press the number 5. And it looks like I was using this for something else, so I'm going to have to delete what I already have stored in there. So I'm going to hit F2 to delete and F1 to confirm that deletion. I'm going to go down to the second and hit F2 to delete and F1 to confirm. So now my y equals screen is clear, and I can go up to the top, and here's my system of equations. So in the y1, let me label this y1, I want to type in 2x minus 4. So 2, and you have to use this button right here as the x. No other button than the one immediately beneath the red alpha key will work as the x. And then minus 4 completes it. So 2x minus 4, and we hit execute to store. And then the second equation we have is y equals negative 2x, and I'm going to store that in y2. So using the negative sign, I'm going to type negative 2x. Again, I hit execute to store that. And after I hit execute, after typing that, this draw option pops up on the F6. So I press F6, and my window range is off. So to get a standard viewing window, you press F3 for a viewing window, and then F3 again for the standard option, which makes the x and y axes both go from negative 10 to 10. So I hit execute to store that, and then F6 to draw. And now that looks much more like what you would graph on a standard graph patch. So I can see that the lines are crossing, but I want my calculator to tell me exactly what the point of intersection is. So I press the F5 button for the graph solver, and then I'm going to press it one more time for the intersection option. And because I only have 2 lines, it pops out with the answer, which is 1, negative 2. So 1, negative 2 is the solution to this system of equations found using my Casio calculator. Are you ready for another? Okay. Okay, so we'll just pretend we're doing an assignment here, because this is exactly what you're going to be doing, right? You're going to be given some problems and you'll have to solve them. And you can, of course, do this by hand, but you paid 80-something bucks. You might as well get use out of your calculator. So in order to go on to the next problem, I need to get out of the screen that I'm currently in. So I'm going to hit the exit button, and that brings me back to my y equals screen. And just as when I started the first example, I have to go back up and delete what I previously typed by highlighting the row that there's typing in, pressing F2 to delete, and then F1 to confirm the deletion. I want to start off with a blank slate every time. So remember to type in x plus 3 in y1 and negative x plus 5 in y2. I have to use the x button that's beneath the red alpha key. So x plus 3, execute. And let me just show you, if I do something wrong, what happens. So if I put minus instead of negative, and I use, I don't know, this x up here, because that kind of makes sense to use that, plus 5, and I hit execute, it took it, but when I draw it, look at what happens. Argument error, press exit. So I exit, go back here, I got to delete it, and start over. So let's do it the right way now. Negative x plus 5, execute, F6 to draw, and once again we can see the lines crossing, but we want the calculator to tell us what that point of intersection is. So I press F5 for the graph solver, and then F5 one more time for the intersection, and I get that the solution to this system is the ordered pair 1, 4. Okay, you ready for the next one? Alright, so here I have y equals 2x minus 1 and y equals negative 3 halves x plus 6. So I need to exit out of the graph screen and go back to the y equals screen, and I need to go up and delete what I previously typed by hitting F2 and F1. Highlight the row, F2 to delete, F1 to confirm. So in my y1, I'm going to type in 2x minus 1. 2x minus 1, and execute to store that. And then in the y2, I have negative 3 halves x plus 6. Now pay attention in this one, because we have a fractional coefficient on x, we have to set up our fraction with this ABC button here. Watch what happens when I press this ABC button. It sets up a fraction for me. And hopefully you can see that in the numerator, the cursor is flashing, so it's waiting for the top number. So I'm going to type negative 3 in the top. Then I have to hit the down arrow to get into the denominator. That makes sense. And I put my 2 in, and I'm still in the denominator, but you look at how I wrote this. The x is next to the fraction. So to get next to it, I need to hit the right arrow. There you go. Now you can see the cursor got much larger, and it's next to the fraction. So I type in the x and the plus 6 and execute to store. Then I press F6 to draw. I can see that they're crossing, and I want the calculator to tell me what that point is. So by now you should be getting the hang of this. F5, F5. And I get a pretty ugly solution. Boy, I didn't plan it that way. So there's my x and my y. It looks like those are going to translate nicely to fractions, but I don't know exactly what. So it might make sense to you. Oh, I see what my problem is. Look at, there's a 1 here, and I typed a 2. So I'm sure you're going to make mistakes along the way, as I did right in front of you and the whole world to see. So I'm going to hit exit, and I'm going to go back up to the row that I typed wrong. And I'm going to press the left arrow, and you see that puts me to the end. I'm just going to delete that 2, type a 1 in its place. So now I can cross off the silliness of an answer that I got. And I'm going to draw. F5, F5. Oh, that looks much better. 2, 3 is the ordered pair solution. And you know, you can always check your answers by plugging them into the original problem to verify that the equality is retained, or that these equal signs are true. So here I've got x and y coordinates, so if I plug this 2, 3 into the original, I've got 3 equals, well, that's a question mark right now, 2 times 2 minus 1. Well, certainly, 3 is equal to 4 minus 1, so that one's good. Now when I plug it in the second one, I get 3 equals negative 3 halves times 2 plus 6. Now when I multiply these fractions, the 2's go away, and is 3 equal to negative 3 plus 6? Yes, it is. So I've verified that this ordered pair works in both of my equations, and if it's a solution to both equations, then it has to be a solution to the system. Let's take a look at another one. All right. In this one, I've got much bigger y-intercepts. So I'm going to exit, is what I've just pressed, delete F1, up, F2 to delete, F1 to confirm. When I look at these two equations that I'm going to put into my y1 and y2, kind of am afraid that they're not going to fit in that viewing window, but let's put them in and see what happens. So I'm going to type 8x plus 34, execute, and 4x plus 14, execute. And this time I'm going to make sure I typed them right so I don't get some kind of funky answer. Alright, looks good. F6 to draw. And even though I'm not seeing their y-intercepts, I can see that those lines are crossing. So for the calculator to tell me where they cross, we use the G-solve with the intersection option, which is F5 2 times. And I get this nice pretty answer of negative 5, negative 6. Now, if you don't mind, I'd kind of just like to make up one more problem for you, or maybe two, to show you some special cases. So let me say y equals 2x plus 4, and y equals, let's go 2y equals 4x plus 8. Now, when you see something like this, when one equation is a constant multiple of the other, that should trigger a synapse to fire in your brain to say, hey, these are the same line. But in case it doesn't, I'm going to solve this one for y first by dividing all the pieces by 2, and I get y equals 2x plus 4. So now we can see that they're the same line, but, you know, maybe you won't. So if we type in 2x plus 4 2 times, and we draw it, we only see one line, obviously, because they're the same line. When one equation is a constant multiple of the other, that means that both lines are the same, and the solutions are infinite. Namely, the solutions are every single point on the line y equals 2x plus 4. Now, one more special case before you tune out. Let's say I've got y equals 3x minus 7 and y equals 3x plus 2. So I'm going to exit out of my graph and delete what I've previously typed by F2 and F1, and I'm going to type 3x minus 7 and 3x plus 2. Now the trained eye might recognize that these are parallel lines because they have the same slope. Oh, you can't even see what I'm writing. Parallel lines because same slope. So, in case I didn't pick up on that and I draw the picture, you could see that they're not crossing anywhere. And if I try F5 2 times, not found, exit. So these last two examples were special cases in which there is not only one solution.